So I was requested to review problems 5, 6, and 7 from Unit 10, Day 1. So pretty much that is the assignment called write recursive formulas for a sequence, which you can find on the Delta Math assignment. So I'm just going to use those examples, so you still get to practice those problems while doing the assignment. But for now, I'll just do a few of the examples from the Delta Math. So first, we're given a sequence, and the sequence is 4, 2, and 0. So it's a sequence, so there's some sort of a rule that we're looking for here. This is our first term, this is A1, this is our second term, this is A2, and this is our third term, this is A3. Now, there's a rule to get from one term to the next, so we can think of a few ways, and it has to work for both of them. So I'm going to change the color here. So we're going to think of all the ways I can get from 4 to 2. So I can get from 4 to 2 by subtracting 2, which is one possible outcome. So this is our first attempt, and it is the correct attempt because we also need to be able to get from, so we can get from 4 to 2 by subtracting 2, and then we can get from 2 to 0 by subtracting 2. But you should always consider the possibility of other outcomes. So for instance, I could also get from 4 to 2 by dividing by 2. So secondly, I would try dividing by 2 as my rule. And 4 divided by 2 is 2, but 2 divided by 2 is not 0. So that would tell me that this rule does not work. But there are also other rules. It doesn't have to be as simple as just one operation. It could be a rule where you do multiple operations. For instance, I can do, like, a third possible rule would be times 2 minus 6. Let me write times as a dot. So times 2 minus 6, because 4 times 2 is 8, and 8 minus 6 is 2. So if we then take 2 and multiply that by 2, we get 4, and when we subtract 6, we get negative 2, which isn't 0. So it fails for the third number. So it fails for the third number for both the third and second formula that I've come up with. But you have to be able to figure out what the formula is, and it has to work for all the terms in the sequence. So firstly, you have to look at the numbers and try and understand, how do I get from one number to the next? And you have to be willing to try it for all the different possible outcomes. So that's the first part. It's finding the general rule of the formula. Secondly, we need to write our rule. So I'm going to erase quite a few things here. I'm going to erase the labels, and I'm going to rewrite the 0. Then we're going to do this one, and then we'll try another one afterwards. So 0 should be in blue here. So our rule is times 2. That's our rule. So first thing, you always need to write down, when you're doing a recursive sequence, what the first term is. So in this case, the first term is 1. Now the rule, A of n, pretty much says to find any term in the sequence, any term, I need to do something to the previous term. So an minus 1 just means the previous term. All that means is if this one was actually the 5th term, I need to know the 4th term. That's all that means. So I have to write, it's like an algebraic representation of this rule. So the rule is times 2. So I just need to say, take this number and multiply it by 2, because that's what this rule is. So that would be the solution to this problem. And we'll fill it in here. So it says 4, type in an minus 1 times 2. Now, this is probably not the accurate way to write it. I should probably write it as, let me just backspace a lot. 2 an minus 1. This is probably the way I would write it. Parentheses might not be necessary. I'll just submit it. Oh, it said I was wrong. Weird. Oh. Whoops, the rule is minus 2. I wrote times 2. So, you got to look out for errors. I kept talking about what the different rules were, and then I wrote the wrong rule. So yeah, the rule wasn't times 2, the rule was minus 2. So we have to write an expression that would imply we start at our previous term, which is an minus 1, and then subtract 2. So you could either put it on the end, would be one possible outcome, or you could have even put negative 2 at the beginning and added that. So this would be one way of writing it. Also, you could write it this way. Either one should have been an accepted answer. Let's take a look at another example, and hopefully I won't make a mistake this time. Okay, we have another example where the numbers are getting smaller. Now, when the numbers are getting smaller, usually that means you're dividing or multiplying by a fraction or subtracting. So we have 8, 2, and negative 4. And I always try to do the easiest version of this first. So I'm thinking, how do I get from 8 to 2? And that would be minus 6 would be the easiest way. Now, looking at the next number, does subtracting 6 from 2 get me to negative 4? And it does. So negative 6 seems to be the rule that connects all the numbers in this sequence. So we're going to write a1 equals 8, because that's our first term. And to find any number in the sequence, we're going to take the previous number and do what to it? Well, we see that subtracting 6 works, so we're going to write minus 6. And that's our rule. I'm even going to put it at the front when I actually enter the answer here. So 8, and the next number would be, I'm going to write minus 6 plus and plus 1. It's the same thing. We're going to look at their answer. So it says we're correct. If we look at the solution that they've given, they wrote a and minus 1 minus 6. So it's the same solution. Let's maybe try one more, just to make sure we're clear. Okay, this one seems different. Let me erase what we have currently. We're going to try to do one more example. So we have 252, and then negative 42. So that would actually be subtracting a lot of numbers. You'd subtract 252 and another negative 42, so minus 294. So that's probably not the rule, because I don't know how I can go from a positive number to a negative number and then a negative number back to a positive number by subtracting. So obviously, subtracting by 294 isn't going to work from negative 42 to 7, so I have to look for a second pattern. So to get it from a bigger number to a smaller number, and the number is changing from positive to negative, I would imagine that I'm dividing in some way. So I'm going to take my calculator. I'm going to try and figure out what I divided by. So it's, I'm going to do negative 42 divided by 252, and this lets me figure out what I divided by. I think I want to turn that into a fraction, so I'm going to press math, press fraction, and enter. So negative 1/6. So the rule here seems to be divide by 6 and change the number to negative. So let me open the paper again. So the rule is to multiply by negative 1/6. So if you want to know what you divide by, you just take any two terms in order and divide them. So negative 42 divided by 252 will simplify to be this. Additionally, if we were to take 7 and negative 42, I go 7 divided by negative 42, I should also get negative 1/6. This is actually called the common ratio, and you'll see it in tomorrow's lesson. So now let's write a rule. So our rule is, let me just change the color again. So our rule is A1 is equal to 252. That's our starting number. And our rule says we're going to take the previous number and we're going to apply this rule. To multiply by that number, I have to put it in the front. So, I mean, I don't need this parenthesis, but I can write it as well. So negative 1/6, and that is our rule. Hopefully this was helpful and clear. You can also press show solution. Well, I can press show solution. Oh, it showed the same thing I did. Oh yeah, these problems where you can divide both numbers and find a number is called the geometric sequence, which we'll see tomorrow. Let's take a look at the problems in the assignment for today that you're having issues with. So how could I get from 9 to 18? That seems like a multiplication, but the signs change, so that's something to keep in mind. Now, from 11 to 23 for this one, I would imagine you can add 12, but obviously that doesn't work here, so there must be a different rule in play. So you have to make a little bit more of an effort to figure out what the rule is. Number 7, I know I went over in the video. This is actually a special sequence, which uses two terms, so it actually you have to write a rule. So for 7, the rule was, I'll just go over it again. To get to 4, I actually need to know the first two rules, and first two numbers, and they give you the first two numbers for that reason, 2 and 3. So the rule is to take 2 and 3, add them together, and subtract 1. So it's the first term plus the second term, and then minus 1 would be the rule. So a more general way to write that rule is if I want to find, let's say, the third term, I would have to take the first term and add the second term, and then subtract 1. But if I were to replace these with numbers, instead of if I were to replace these with variables, this would be bn, and then 1 is 2 before that, so I write bn minus 1. Well, not minus 1, minus 2, because it's 2 before the n, and this one would be 1 smaller than 3, so that's b n minus 1, then subtract 1. So this is the formula for this sequence, but this is a special sequence that uses more than one number in the rule, but usually they don't. If you have any questions,